Okay, then let's start. So my talk is about Groovy integration testing with Spock and Docker. So you might see some familiar stuff, some new stuff. And yeah, of course, it's about integration testing using Groovy as a language and as a tool. But I think the patterns I'm going to show and the tools I'm going to show are also Groovy in itself as the adjective. So a little bit about me. My name's Kevin Wittek. I'm from Germany. I work as a software developer at GData, Advanced Analytics. It's a sub-company of GData, the antivirus company, but I have nothing to do with antivirus software. I also have my own company called Strakosoft, and there I'm doing some consultant work, helping in setting up build pipeline for customers and so on, and yeah, doing some generally consultant contracting work. I have a website, a blog, Groovy Coder. It's a cool domain, I think, and there I blog about testing, about Spock, about Spring, but in not such a high frequency. And yeah, that's my Twitter handle and my GitHub. So, what I'd like you all to learn in this talk, it's not about the tools I'm going to present, although they are quite cool as well. What I'd like you to realize that nowadays it's quite easy to set up a complete and portable test environment for yourself or for an open source repository or for your company. And nowadays there's not that much effort needed to do integration testing with real external applications like databases, or if you have to use an FTP server or whatever. And one of my goals, or I'd like to see as a goal for the community as a whole, is that in the future, if we have a project, it might be an open source project, it might be an enterprise project, you just have to check it out with a git clone, you do a Gradle build, and everything will build, including the integration tests, spinning up your databases whatsoever. You don't have to install any dependencies. And yeah, that's one of the goals I'd like to see for us as a community. So before we go into the technical stuff, I said it's a talk about integration testing. So let's discuss the semantics here real short. Where is integration testing positioned on the testing pyramid? I assume most of you know this testing pyramid. There are different versions which distinct in certain details. I like this one, and yeah, I think all of you might know this. You have most of the of your test suite should be composed by unit tests at the bottom. Then on top of it, you have this block, which is kind of all integration tests, maybe. So you can subcategorize them into component test, then classical integration test, API test. And I think, as we see, because of the broken line here, the borders between these different test sets are kind of, yeah, how do you call it? They are not close, these borders, they are flowing into each other. And then on top of this, automated GUI test. And of course, you should have some manual session-based testing at the very top. And the stuff I'm going to show you applies from everything, or should apply from everything up from the unit test. So, of course, for integration tests, but also if you think automatic GUI test, Selenium-based test, whatever. So, yeah, this is a classic testing pyramid, and this applies really well for monolithic applications, web applications, and so on. What about microservices? Is the testing pyramid for microservices still built the same way? Maybe it is, maybe it is not. I've looked into some blog posts about it, and then I found this cool picture on Martin Fowler's blog. It's about different layers, testing layers for microservices. It's very complicated, but yeah, there might be some truth in it. I think we all might have to rethink some of our testing strategies if we continue to go further into the microservices architecture world. And the tools I'm going to show you will also help you in these architectures. So Now, my definition, what I'd consider an integration test for the sake of this talk, there are all tests which interact with external systems or dependencies. So, for example, if you have a Spring Boot application or a Grails application, if you spin up your application server for the test, that's something I'd consider an integration test, even if I'd call my Java classes directly and not through the API. And yeah, everything regarding things like Spring or Grails, every test which involves your whole framework, like the Spring framework or the Grails framework, that's something I'd consider an integration test. So testing your integration with the framework. And the classic examples are, of course, if you're testing real external systems. So if we're thinking hexagonal architecture pattern here, if we are interacting with the external ports. So for example, a network layer, the file system directly, or the database. So now, which tools do we use in the JVM world to help us integration test? Yeah, I think most of you know most of these tools. I'll introduce them real quick once we get to the point all. And of course, since this is a Groovy conference, Groovy is at the core of this testing strategy and testing philosophy. So I assume all of you know and use Spock. Who knows and uses Spock here? Some not, I think, yeah. So really quick, it's a testing framework. They call it enterprise-ready specification framework. It's kind of a substitute for JUnit in the Groovy world. You can use it to test your Java classes as well, your Java code, by writing Spock code, Spock tests, which are itself Groovy code. And here we have a small example I took from the official documentation. So yeah, that's Groovy code, and Spock basically has its own DSL, which is used to specify tests in a more rich and natural way, maybe. So what's really cool in this example is the where block. That's something which is called Spock data tables, and you can use it for something called data-driven testing. And what Spock will do, each entry in this table, so each row will be used as input for another test. So it's like we have defined 3 tests here. It's the same as JUnit's parameterized tests, but I think the syntax is a bit more convenient. And you also have these, I think, power asserts, it's what it's called. You have some blocks like this expect block, or there are other blocks like the then block, in which every expression is evaluated as a Boolean expression and in the context of an assertion. So if you write it like this will already be used as an assertion of your unit test in this case. Yeah, so we've seen Spock. And now let's come to another tool I'd like to introduce for integration testing, for helping us integration test. It's Docker. Who here knows and uses Docker? Yeah, some, but not all. So let's have a quick introduction into the concepts of Docker. So some people say Docker is actually like a virtual machine, and that's a really bad example. You shouldn't compare them to. Compare both technologies in this way. So what Docker basically is, it's a container platform, and you have your kernel, for example, your Linux kernel, and on the kernel you have different containers, Docker containers running. Inside these containers you have the complete user space, so to say, of your distribution. For example, if you want to build a container which is based on a Debian, you have this Debian user space binaries inside. You can add Java and Tomcat, and there you have a Java application which you can deploy and run and operate as a container. And the nice thing about containers is that they are very technology agnostic, regarding the software you put into it. So we have other examples. Here there's a Microsoft stack in the middle, and what's really nice if you simply put a static binary into a container. You basically only need a really thin user space distribution layer like Alpine, or for example, if you compile static binaries with Rust or Go, you don't need anything except this static binary in this container. So now, yeah, a quick comparison between a container and a virtual machine. As you can see in the container world, all containers are running on the same Docker engine, which itself runs on the kernel, so all containers are running on the same kernel. In the virtual machine world, however, we have the hypervisor, and each virtual machine has its own exclusive operating system. Yeah, so they don't share anything regarding kernel or operating system, only the hypervisor stuff. And of course, you can mix and match both. It's totally fine to run Docker containers itself inside a virtual machine if you want this additional isolation. So there might be really a lot of valid use cases. For example, if one container might crash your kernel, all other containers running in this virtual machine or on this host might crash as well, or will crash as well. So, why do we want to combine both technologies? Yeah, as I said in one of the first slides, I'd like to have an easy setup of a development and test environment, and using Docker in this case, we might even reach the point where we have a uniform build and test environment on all environments, like on the developer's laptop, on your CI server. It's the same everywhere, and it's kind of portable. You just need to check it out, run it. You don't have to set up anything before. Yeah, like I said, there are no installation and setup of external software. And that's basically one thing we might achieve in the future. Now, yeah, how do we combine both of those worlds? Yeah, I had the idea of writing a Spock extension for using Docker in my Spock specifications, and I thought, yeah, Spock with Docker and a name Spocker, that would be funny, but that's not the official name. And now I'd like to quickly introduce the way this extension was developed and how it has changed in the last month. So the first commit was basically I wanted to have an annotation I could put on my test class or even on my test method. Here, like add Docker and specify an image and maybe a port I'd like to bind to on my host server. And yeah, then it would spin up the container before the test and tear it down afterwards. Yeah, that's basically what the first commit looked like, and it did work. It did basically do the job for what I wanted to achieve in this place. That's the implementation of this Spocker extension, basically. So all it's doing, it's starting the container before the specification starts, and then stopping the container afterwards. So really simple. And yeah, this is a bit longer. This is implementation using the Docker Java client, which is quite verbose and not that nice to use, but it's okay, and it's one of the most widely used Docker libraries in the Java world. And yeah, then I switched, after I wanted to add more features, I switched to the Groovy Docker client by Tobias, and I really could throw away most of the code I had before, all the boilerplate and verbose stuff of the Docker Java client. I could remove it, and yeah, that's a great library. So if any one of you want to do something with Docker inside Groovy, use this library. It's great. It's very similar to the Docker REST API, and since you've implemented in a really dynamic way, it nearly is upwards and backwards compatible all the time, because it delegates everything to the Docker REST API. Works fine. Yeah, so then this happened. Sergey raised an issue in the GitHub project, and I'm very thankful that this happened because this brought the whole plugin onto another track. And he said, yeah, nice what you're doing there. We actually already have something like this in a more mature way. Maybe you'd like to contribute to this project instead. And yeah, that's basically what happened. So what he's writing here about is the test containers Java project. And now I'm quickly introduce this project. Yeah, it's called test containers. It's a library for using Docker containers in your JUnit test. And it basically already has all the API stuff I wanted for my extension. It does other neat stuff like supporting Docker Compose, like cleaning up containers afterwards if something happens. So they have this reaper process running in the background which kills the unused stuff. Really convenient to use, and yeah, I tried it out in a branch, and I thought, yeah, that's fine. Let's simply use this instead of developing all the stuff on my own. And this is an example how you would use this in a JUnit test. Using a class rule, I haven't used JUnit for a long time, so I'm not really sure what class rules or other rules do. I assume it's yeah, they run the thing before the class and afterwards, this rule, whatever. And that's basically how you can use the containers in this case. So no annotation here. You define a field in your JUnit test. In this case, it's a generic container, so it could be any container you configure yourself. You define an image. It's a Redis image with a version, just a typical Docker style. And then you have additional API stuff like here an exposed port. And yeah, it will do all the work for you. Yeah, that's the general feature set. So it supports generic containers, any container you want. It provides some specialized containers. We'll see them in the demo. It has support for Docker files, so it could build your test containers on the fly in your test based on a Docker file. And it even has a Docker file DSL to define it inside your test code, the Docker file. Supports Docker Compose. We'll see Docker Compose later in the demo. And it has something really neat, which is called a wait strategy. Because, you know, if you start a container, for example, a Postgres container, and in your test, you want this container to actually run the application inside in such a way that you can connect it and use it. And if you run a Postgres container, it normally accepts TCP connections and then later JDBC connections on port 5432. And so what happens if you start the container and directly interact with it? The database inside isn't set up. So what many people suggest in the Docker community is to wait until the TCP port accepts connections. If you do this with a Postgres database, the TCP port will accept the connection, but the database isn't initialized yet, so it won't accept JDBC connections. And this wait strategy stuff handles this for you. You can have a JDBC wait strategy or HTTP wait strategy and check if an HTTP URL is reachable inside your container, and then the tests move on. So then the first thing I did was I substituted the Groovy test client library with the test containers, and still used my own facade classes in front of them because I thought, yeah, maybe I've switched to 3 different library implementations now. Maybe I'll switch to the 4th next week, where I don't know. And but it generally was a plug-and-play replacement in this case. So that was already nice. And then as the features started to increase, since I've used this annotation-based approach, I had to basically duplicate the API test containers already provides on my annotations. And one might say this gets kind of messy, and it gets even messier if you add more and more features. And I also had to keep up with copying all the API into the annotation, and that was no fun at all. So then I thought maybe there is another approach here, and I totally switched the way the Spock extension works. I only have one annotation here, test containers, and what this annotation will do this extension will do, it will allow Spock to scan the specification before running the tests. It looks for generic containers as fields, and then it will start them up, tear them down afterwards, just like before, but you can conveniently define them as fields. You can also use the Docker, the Spock at shared annotation. So for example, if you annotate a field with at shared, this container will be shared between all your tests. If you don't annotate it with at shared, a new container will spin up for every test, so for every feature. Okay, and now we come to the demo. Cool. So sadly, that is a Spring Boot app, not a Grails app, but I haven't used a lot of Grails in the last year, so I went with Spring Boot because I have more experience using Spring Boot. Who here knows and maybe uses Spring Boot? Yeah. And who uses Grails? Okay, and after all, Grails is nowadays built on top of Spring Boot. So the general concepts might be the same. The application I'll demo here is a basic Spring Data application. We have a real stupid entity, a book, Hibernate entity, a JPA entity, and we have a Spring Data book repository. And yeah, we also have a customer, but I'll come to this later. So let's look into the shared database test at first. Now, the stuff I have to do to get this working with Spring Boot are kind of complicated, but that's not a problem of the test containers library. That's kind of a problem with Spring Boot Spock or Spring Spock integration, because you have to set up some stuff before the application actually starts. So, as I said, this is a test containers annotation. This will tell Spock to scan the specification for containers as fields. And here we've defined a Postgres container. That's a specialized class which has some convenient API methods, helper methods, like you can already define a database name and username and password and so on. If you would use a generic container in this case, you could also do this, but you have to define these values by using environment variables, but basically it's the same. But what this container also does is it automatically waits for the JDBC connection to be available. So what I've mentioned before, this Postgres container does for you. You don't have to do it yourself. So now the problem is if we want to spin up the container in such a way that the whole test environment is really portable, we can't assume anything about the host system it is running on, like which ports are free, for example. So you might run it on a CI with other tests running there. You might run it on your local machine with another application running. So you can't, on another database running. So you can't bind the container directly to a port, to a specified port on your host, because this, as I said, wouldn't be portable. So what test containers does for you, it basically binds to a free port, and then you have an API to get the resulting port or even IP or whatever, because of course you could use a Docker engine, a Docker daemon running on another machine, and it would be totally transparent for Docker in that way, and then you would get the corresponding URL in this case. So what we do here, this is Spring Boot stuff. We define our own application context initializer, which will set stuff like the Spring Data Source URL, username, and password as environment variables before starting the application, so the Spring context. And as I said, we do this because we don't know before running the tests on which port or maybe even on which IP the test database container will be running. And this is a totally dirty hack with the static variable because the initializer must be a static class here. Yeah, so we can use it here in the annotation. That's just Spring stuff. You don't have to care about. Yeah.
Just to note that Rob from Spring Foundation discovered test containers and was inspired. So he did a proof of concept how to use test containers for Spring testing, and they will improve Spring testing for test containers. So just maybe in a few releases of Spring testing, it will be much easier to do this. So basically, you don't have to do any of those. So just in a few months, maybe we'll get better support from Spring. So don't be afraid of this code.
Yeah, that actually I think a copy and paste example you can get from the test containers example projects. And what I did here in this case, I have an abstract class, and then all my tests which use the database could simply extend this class. So let's look into, and yeah, as I said before, we can also use Spock's annotation like shared or not shared. So this test will use this container for all tests inside the specification. That's why it's called shared database test. So that's the test. I've used the Spock at stepwise annotation so we can see what's actually happening. What we're doing here, we look, the repository is empty at first, then we save a book into it, and afterwards it contains a book. Yeah, great example. But it shows you how it's done basically. So now we see lots of output from the underlying Netty library communicating with the Docker socket. Let's hope it works. Yeah, the Spring Boot application starts up. Hibernate is doing its stuff. These exceptions were because of something else, nothing bad. And yeah, we see it works. And if we do, oh, can't I do a breakpoint here? So if I break here, and then we'll look into the, oh yeah, there we see it's running. Oh, why is there the Selenium running? I don't want this. Okay, cool. So we basically see the library has spun up a container, and we see it has mapped onto some free port on the host, and it's mapped to the internal Postgres port there. And if we continue running the test, yeah, there's no more container. So it cleans up for you after the test. Okay, so that's one real basic example using a relational database. And of course, you might argue, oh yeah, I use H2 in memory database after all. Yeah, it's okay too, but you have to. It's a trade-off. H2 might be faster, but in this case, you can be sure that you are integration testing against your real external dependency in this case. So you have to decide. It's okay to use memory databases as well, but it's very easy and convenient to use a real new database in this case as well. And now let's see something maybe even cooler. Assume we have also a Mongo database we use in our application. So we have this, oh, I switched to presentation mode again. So we have this Spring Data Mongo repository, and it's basically the same thing we have to do. So we define, in this case, a generic container. And yeah, it will boot it up as well. I've also defined the Postgres container here, so Spring Boot will start up successfully. And then we inject the configuration, like the IP address and so on, into the environment variables. And if we go into the test, yes. Okay, it's basically the same test, but this time using a Mongo database instead of Postgres. So stepwise as well, to have it stateful all the time. And in the beginning, the Mongo repository is empty. Then we save some customers, and then we can search for them. Okay, yeah, that's it. So that's an example of using the test containers library for basic integration testing of your application. But we can do even more. So who of you knows Docker Compose? Okay. Docker Compose, it's a tool from Docker Inc. as well, and it's basically a tool to define a service or define a system which might consist of multiple services which are itself Docker containers. So, yeah, let's assume we have an application which looks like this. This is an example application by Docker, and they used it at the DockerCon last year all the time for demonstrating stuff. We have a front-end application, which is a Python application. We have another front-end application, which is a Node.js application. We have some persistence stuff below, and then we have a worker service, which will take stuff which was written into the Redis persistence layer and write it into the Postgres database. And the Docker Compose file you'd write for this looks something like this. So it's a YML file, and you define your different services and some more stuff. You can just look it up. It's quite simple to use. And now, of course, what we can do with Docker Compose, we could define our whole application, our system as a whole, spin it up using Docker Compose, and then test this application with something like Selenium to do real functional and UI testing and so on. So what we'll also use for this is JEP. I think all of you, who knows and uses JEP? Yeah, we even have an author here. Okay. So yeah, what it basically does, it's a DSL for Selenium, I'd say. Do you agree, Marcin? Yeah. Okay. Yeah, it has a really nice Spock integration as well, and yeah, this is an example from the official documentation. You basically say, tell it what to do, tell the browser what to do, like visit this page, click on this button, whatever, and then you can also query the resulting DOM and assert that the things happened as you expect. And yeah, let's demo this stuff now. So maybe before I'd show you the test, I quickly show you the app we will test. Oh, that's the wrong one. That's the wrong one again. That's all right. Okay, so to run a Docker Compose project, you have simply to type Docker Compose up, then we'll start up all the stuff and so on, test some internal DNS networking, everything. Yeah, really convenient. And yeah, let's see how it actually looks. Okay, So this is a voting app where you can, on the one front end, you can vote between different stuff, and then we have another front end where you'll see the result. So if I do like this, it changed. Yeah. Okay, so that's basically our application. We've seen it consists of 5 services. If we do a Docker PS, we should see them here. Yeah, that's basically the services I've shown you on the diagram. Let's turn this off again. Okay. Now we can, as I said, test containers also has Docker Compose support. So here we can define a Docker Compose file, which will be used to spin up my containers. And you also can define which services you want to expose. This will be the services with which you will interact in your test. And yeah, you can say with local compose, then it will be the compose which is it will use the compose which is installed on your system. I've said with pull false because I have no internet connection here. Else it would automatically pull the latest versions or whatever. And yeah, the next thing, it's also cool. That's another container class which is already built into test containers as its own dependency, as its own library, basically. You have this browser WebDriver container, and this container consists of Selenium and basically the capabilities you define here. We say Chrome, so it will contain a Chrome running inside this container. Then, oh, this is actually not needed anymore in the newest version. This version was still lacking the Docker Compose support. So this version of test containers. So yeah, as you can see, I don't even have it annotated with at test containers. So I'm using the test containers library here in my Spock test directly, as you would maybe use it in JUnit, and so on. It works fine as well. So you, to be honest, you maybe don't really need this Spock extension for test containers, but it's for you to decide. It saves you some boilerplate stuff. So here I say I will start the compose before my specification starts. Then I do a little hack because we're still lacking Docker network support, kind of. What I'm doing here is I connect the Selenium container, which was also started, to the Docker Compose network. So the Selenium will be able to access the Docker Compose services using DNS, which is just more easy. And yeah, then it starts. And what the JEP test does, it visits the vote page, it looks at the correct text is displayed, then it visits the result page, then it will visit the vote page again, it will click on the Groovy vote, and then it will visit the result page again, and it will verify that the result has changed. So let's just see it in action. Does anyone know how I can do debug run with a shortcut? Okay. So I want to. Oh no, that's the wrong. Yeah, here we go. So I have this breakpoint here. Here, there, because we'll be able to connect into the running Selenium container, which itself runs a Chrome, using VNC, and then we can see the whole test in action. Okay. Yeah. Okay. So this container conveniently allows you to access the VNC location here, the VNC address, Then we put it into our VNC client. Yeah, there it is. Container running on our machine. Now we continue the test. There we've seen it's already visited this page. Visit this page, clicks there, buff, buff. Yeah, that's basically it. So no setup needed by the developers, no installation of Selenium, no Selenium infrastructure. You can run it on your local machine as you can on your CI environment, and yeah, really convenient, I think. Okay, it's not set up. Okay, so what about? Yeah, I think I have to skip this part. It goes a bit further. If you run your CI inside a container, so if your CI spins up a container to do all the stuff, things might get a bit more complicated. There are different patterns you can use to create new Docker containers inside a container, Docker wormhole pattern, and so on. It's more complicated, more sophisticated, but it's all stuff you find solutions for in the internet. And of course, you can ask me about it later or whenever. Okay, the future of the Spock extension or the test containers Java library in general. I hope we get better support for Docker networking. In this case, we can rely totally on a service discovery mechanism like DNS, and we don't have to retrieve the actual IP and the port. This would be very convenient, and I think it should be possible. I'm not sure about the current state of the underlying Docker Java library, if it supports the Docker networking, but yeah, I think this will come in the future. Also, I think we have to do some more improvements on Windows, as Sergey at least did allow Docker containers to be running with test containers under Windows, but I think we're lacking Docker Compose support still.
The current state is that Docker machine is fully supported, and Docker for Windows is partially supported, mostly supported, I would say, and as well as other environments. May I ask just for a second that when you listed all the features, you actually missed one really important one. Test containers does a huge job to find Docker on your machine. Being able, sorry.
Okay, it's even able to find Docker if you run test containers test inside a container on Jenkins, for instance. So it is able. Test containers is mostly about the discovery of Docker on your machine, plus some convenient methods to run them. But Docker discovery is one of the hardest part of test containers. And yes, we do support Mac, Linux, Windows, Docker machine on both Mac and Linux, both Mac and Windows. Just wanted to mention it because it's really important. Like,
yeah, thanks. Yeah, so and something I'd also like to see in the future, which might already be possible if we combine the right Gradle plugins or whatever, is support to build and test inside a container with full IDE support, meaning IntelliJ. Like the test we've seen, that everything is run inside the container and invoked from the IDE, so the IDE parses the output and knows which test has failed and so on. You can, of course, do all this if you run it from a command line, but I'd like to see some IDE support there in the future. Okay, resources. I'll also publish this presentation online. I'll tweet it, and there you have the GitHub repositories from test containers Java, test containers Spock, the both example projects I've shown you, and of course, if you start using Docker, there's a lot of documentation, official documentation on Docker. And yeah, that's basically it. So I think we see Docker and the Java community and ecosystem work well together. And yeah, thanks for your attention. I hope I could inspire you, give you some ideas about integration testing, and thank you. Don't know if we have time for questions. Yeah. Okay, and you can ask me, of course, over the course of the next days as well, if anything.